Hello friends, so the question is check for the convergence of series un where un denotes the general term of this series and is equal to 2 raised to minus n minus minus 1 raised to n. And clearly this is a series of positive terms, right? So let's see the procedure to find or to check the convergence of this series. Okay, so here the general term of our given series is un equals 2 raised to minus n minus minus 1 raised to n, right? Okay, so let's try to simplify this a bit. Okay, so the given un, let me try to simplify it. So it will be un equals, so I'm going to write it as, can I say this is nothing but equal to 2 raised to minus n plus minus 1 raised to n. I hope this is fine. Okay, so which can further be written as un equals 1 upon 2 raised to n plus minus 1 raised to n, and which further could be written as 1 upon 2 raised to n times 2 raised to minus 1 raised to n. So this much simplification was required. Okay, so next, so now here, why have I simplified it in this way? Because I'm trying to approach towards the Cauchy's root test, which I'm going to use here to check the convergence or divergence of the series, right? So basically, for Cauchy's root test, in Cauchy's root test, we are required to find the limit of un. So basically we will be finding the limit of this quantity. So let me erase the other things. Okay, so now we required to find limit n tending to infinity. I'm sorry, we don't need to require to find a limit of un, but we require to find the limit of this un raised to 1 by n, where un has to be the general term of a positive term series or a series of positive terms, right? So this is something which we require to find. Okay, so let's proceed. So this will be limit n tends to infinity. Okay, so un is this 1 upon 2n 2 raised to n, all right, times 2 raised to minus 1 raised to n, and this whole factor raised to 1 upon n. Now, which is further equal to limit n tends to infinity 1 upon 2 raised to n raised to 1 upon n times 2 raised to minus 1 raised to n upon n, right? So this power is distributed with the individual factors in the denominator, right? So this limit is further equal to limit n tends to infinity. Yeah, so this is going to give us 1 upon 2 times 2 raised to minus 1 raised to n upon n, right? This thing. Okay, now this thing is going to be equal to 1 upon 2, How? Because if you focus on this factor out here, let's check it out in scratch work. What will be the limit of this factor? So basically, limit n approaches infinity, 1 upon 2 raised to minus 1 raised to n upon n. Okay, so if you focus on, I should say, this factor, this power of 2, right, we'll get to know when we raise n to infinity. So whatever be the numerator is going to be minus 1 or 1, but the denominator, when tends to infinity, will make this power as 0. So which makes this entire limit to be 1 upon 2 raised to 0, which is nothing but 1, right? And hence this limit is 1 by 2. Now what? Now Cauchy's root test says if this limit will come out to be less than 1, then we say that the series summation un is convergent, right?